Hello students, welcome to Vijetha IS Academy, New Delhi, and myself is Lenin Kake and I am the faculty of Geography and Science and Technology in Vijetha IS Academy. And in this video, we are going to discuss a small topic regarding quantum computing. Okay, so what are quantum computers and how they are working and what is the difference between these quantum computers and classical computers or normal computers, whatever that are there. And also what are the initiatives that government of India has been taken with respect to these quantum computers. Everything we'll see in this small video. Is it clear? So let's start the video. Okay, so quantum computers, see there are two types of physics are there. One is Newtonian physics or classical physics will be there. Okay, Newtonian physics and quantum physics. Okay, so in Newtonian physics, whatever the things that we are seeing today, okay, like say for example this pen is there. Okay, so whatever that is there, that we are observing these things in macro level. Okay, so in macro level, see this macro level is nothing but called as this Newtonian physics. Newtonian physics works on this macro level. For example, any ball is there, okay, or we are riding a bike. Okay, so any bigger objects are there. On those bigger objects, whatever the physics that is operating is nothing but called as Newtonian physics or classical physics. Okay, and there is, see in this one we can say everything with convection. Okay, like this is called as okay, it is deterministic in nature. It is deterministic in nature. For example, say if you see this quantum computing, it is working at very minute levels. Okay, for example, this quantum computing is working at the level of any atoms, or it is working at the level of electrons, or it is working at the level of protons. Okay, at very macro level, at very micro levels. Okay, smaller levels, whatever the computing that is active, means whatever the physics that is operating is called as quantum physics. Okay, so quantum physics is operating at the level of atoms, electrons, protons, neutrons, all these things, and classical or Newtonian physics is operating at the macro level. Okay, and this is deterministic in nature and this one is probabilistic in nature, because we cannot say with conviction that okay this one is this. Okay, like that we cannot say in this quantum physics, but in this one definitely I can say, for example, I am throwing a ball, definitely I can say this ball is going to come down because of gravity. Okay, with that confidence we can say in normal Newtonian physics that okay, so hence it is called as deterministic in nature. But in this quantum physics we cannot say with conviction that okay this will happen like this only, like that we cannot say in this quantum physics. Okay, that's why it is called as, it is probabilistic in nature. Okay, this one is probabilistic in nature and normal physics or Newtonian physics is deterministic in nature, and this will operate at macro levels and this one will operate at micro levels. Okay, these are the two major difference between this Newtonian physics and quantum physics. Okay, and we have to know the same principle where we are using these atoms, electrons, protons at this micro level or at this micro level. Okay, the same concept will be used in this quantum computers also, where so we will try to store the information and we will try to retrieve the information at this micro levels. Okay, at this atomic levels. Okay, at this atomic levels we will try to store the information and we will also try to retrieve the information at this smaller levels. Okay, so whatever the physics or whatever the computing capacity that are there at that levels are called as quantum computers. And we also have to know what is the difference between these classical computers and also this quantum computers. Okay, so in classical computers, if you see in classical computers, the information will be processed in the form of bits. Remember, the information will be processed in the form of bits in classical computers, but in quantum computers the information will be processed in qubits. Qubits is nothing but quantum bits. Okay, this is the UPSC has asked qubits, the term is related to which of the following? 1, 2, 3, 4 options have been given 2 years back in the UPSC. So every term is important for our exam. Okay, so the normal information, the information will be processed in the form of bits in classical computers, and the information will be processed in the form of qubits or quantum bits in this quantum computers. Okay, so how they are operating in the bits means, see, for example, if I take 0 and 1 time, if I say it will be either in 0 state or either it will be in the state of 1. Okay, it cannot be in simultaneously, it cannot be both 0 and 1. Okay, so anything if it is there, then it will be there either in single state only, either it will be 0 or it will be 1, but it cannot be both. Okay, it cannot be in both states. But in quantum computers, any object or anything can be there in two locations simultaneously or in two states simultaneously. For example, we can say it will be, see, 1 0 or 0 1 or 1 1 or 0 0. Okay, so how many possibilities have came here? 1 2 3 4. 4 possibilities have been occurred here because of the same two events. Okay, because of the same two events, how many? 4 possibilities have been occurred here. But here, because of two events, how many possibilities are there? Only one possibility, either it is 0 or either it is 1, but never both. But in this case, it can be 1 0 or 0 1 or 1 1 or 0 0. So there will be a chance of increasing the probability of these things. Okay, so the number of events have been increased. In this computing also we will use the same concept, because once the computational power, with this the computational power has been increased, right? So with this one, the same concept has been used in this quantum computers, where the computational powers of these quantum computers will be much higher than these classical computers. Okay, so where the information will be processed in the form of qubits in this quantum computers. Is it clear? So if you see, okay, it is based on quantum mechanics model of atoms. In this individual atoms, ions, molecules, electrons, photons are used to store and retrieve the information. So conventional or classical computers process information in the form of bits, either 1 or 0, following classical physics. Okay, and the information either as 0 or 1, but not both. But in this quantum computers, they process the information in the form of qubits, okay, or called as quantum bits. Okay, and they will exploit the same property of this quantum mechanics, where we can say they can process the information 0 and 1 simultaneously, means both of them can exist at the same time, and there will be chances of increasing the probability of this existence also. Okay, so that state is called as quantum superposition. Okay, remember what is quantum superposition also, but I think you have understood the basics of this quantum computing, where the information will be processed in qubits. There in classical, the information will be processed in bits. Okay, and here the information can be there in both the states simultaneously, but there the information can be there only in single state at a time. Is it clear? Okay, so the basic principles or properties on which this quantum physics or quantum computing are working are 2 in number, which is quantum entanglement and quantum superposition. Okay, remember these are the basic properties on which the quantum computers are working. Okay, so this quantum entanglement, in 2022 quantum entanglement has been awarded the Nobel Prize. Okay, for this one they have awarded Nobel Prize, where in quantum entanglement, remember, whenever any quantum bits, okay, or whenever any two events, okay, when they are brought very close to each other and if they are paired against each other, okay, if any two events which are there, when they are brought very close to each other and if they are paired against each other, then after separating to how much distance it might be separated, okay, and if any disturbance has been made in one of the event, the same disturbance can be observed in the other event also. Remember, if any two events or if any two particles which are brought very close to each other, and once they are paired against each other or entangled against each other, and after that one, if these two particles are separated by any distance, okay, once they are separated by any distance, if any disturbance has been made in one of the event or one of the particle, the same disturbance will be seen in other event also. Okay, so they will simultaneously, if this one is moving, this one will also move simultaneously, means they will travel at a fraction of speed, means they will travel at the speed of light, very fast this information will try to travel. Okay, so this property is called as quantum entanglement. Okay, quantum entanglement is nothing but they will be paid, and after traveling how much distance might be, if any disturbance is making in one thing, the same disturbance will be observed in other event also. Okay, the same concept has been called as quantum entanglement, and for this concept they have been given Nobel Prize in 2022, where they have paid two particles very close to each other. Previously also for quantum entanglement they have given one Nobel Prize, and this is the second Nobel Prize which has been awarded to this quantum entanglement. Okay, so the next concept in quantum superposition. See, quantum superposition is nothing but earlier which we have discussed that simultaneously any object can be there in both the states. Okay, means for example, let us assume I am going to flip a coin. Okay, once I am going to flip a coin, either it can fall as head or it can fall as tail, right? Okay, only once it is, see, this is the coin which I am going to flip. Okay, so once this coin has been flipped, after reaching the ground, either it will fall as head or either it will fall as tail. With convection I can say either it will fall head or it will tail. But can you say anything when it is in the air? Can you say anything when it is in the air? No, we cannot say. There is a probability that 50% probability will be there that it can fall as head or it can fall as tail, right? So when it is in the air, we can say it is both head and tail. Okay, once it is in the air, we can say both head and tail, because we don't know which one it is falling. But after falling, we can say, we can see it and tell, okay, it has fallen as head or it has fallen as tail. So whenever it is in air, we can say it is both head and tail, means simultaneously it is showing both the events. Okay, we'll take one more example. Okay, Schrödinger has given one more example regarding this quantum superposition, where he has taken a box. Okay, cat in the box paradox. Cat in the box paradox, where in this box they have placed one cat. Okay, they have placed one cat in this box. Along with this cat they have placed some poison. Okay, in this box they have placed one cat. Along with this cat they have placed poison also, and they have closed this box. Okay, so now once this box has been closed, we can say there is a probability that either the cat has been dead or the cat has been alive, right? So there might be probability of both. It can occur, either there might be the chances that the cat has been died or the cat has been alive. Okay, so but once the box has been opened, then directly we can see and tell whether the cat is alive or dead, right? But before opening that box, there can be chances that both the events can occur, means both the events can be, the cat can be alive or cat can be died, right? So these both events can be there simultaneously when the box is closed. But once the box is open, then only with convection we can say, okay, yes, the cat is died or the cat is still alive. Like that we can say only the box is open. But till the box is closed, both the events probability will be there whether it can be died or it can be alive, right? So simultaneously both the events can be there. That thing is called as quantum superposition. Okay, quantum superposition. So quantum entanglement is nothing but when any two objects which are brought very close to each other, once they are paired up, and after taking how much distance are separated also, then if any disturbance is brought in one event, that the same disturbance can be observed in other event also. This is called as quantum entanglement. The second one is quantum superposition, means any event can be there simultaneously in different positions. That is nothing but called as quantum superposition. For this, Schrödinger gave cat in the box syndrome, and another example we can take it as flipping a coin which can fall either head or tail. Is it clear? Okay, for this quantum entanglement only they have given Nobel Prizes twice, and the recent Nobel Prize was given in 2022. Okay, so see 2020 in we'll see there. Okay, so we'll see what are the Government of India initiatives with respect to these quantum computers. Okay, what are the quantum computers? Because see, here we have seen because of quantum entanglement, whatever the disturbance that has been occurred in this one, the same disturbance has been seen in this one also, right? So using this concept we can communicate the information very fast, okay, because the same thing, if disturbance is there in this one, the same disturbance is occurring in this one also, okay. So the information can travel very fast. So using this one we can use this same concept for interplanetary communications, okay. Interplanetary communications can be done using this same quantum computing technology. And also as they are traveling very fast, we can use the same concept for encryption also, okay. So because once encrypted thing is there, then hacking thing will become very difficult, okay. In the light of this data, okay, in the light of this data, okay, so whatever the mobiles, we are generating huge amount of information, right? So we are prone to lot of hackers, right? So if you start using this quantum computing, whatever the technologies that are there in this quantum mechanics, okay, so we can use this encryption so that hacking can be reduced, and we can also pass the information very fast, okay. And also we can communicate the information with the other planets also. For example, if someone is there in the Mars, we can communicate with them in the Mars very fast, okay. Like that we can do. And there are a lot of other applications also using this quantum mechanics, where we can try to find new drugs also, because it will do calculations very fast, right? You can see all the probabilities, so we can innovate new drugs, vaccines, all these things. And also we can test the drugs also, whether they are working or not, what is the probability of working that one, whether it will work or not. All these things we can test using this quantum computing technology. Is it clear? So because of that one, India has been investing or doing a lot of things with respect to these quantum technologies. And some of the initiatives that Indian government has been taken with respect to this quantum computing is QUEST, okay. So this QUEST is nothing but called as Quantum Enabled Science and Technology. It started by this Department of Science and Technology. And the next one is TIFR, Tata Institute of Fundamental Research, has a program called Quantum Measurement and Control, QMAC program is there. And IIT Roorkee along with CDAC came up with the quantum simulators, QSIM. And the most important thing is quantum mission, okay. National Mission on Quantum Computing. National Mission on Quantum Computing was also bought by Government of India, where Government of India has allotted around 8,000 crores, okay. Around 8,000 crores have been allotted for this National Mission on Quantum Computer, where they are planning for a lot of research on these new technologies, okay. Research on these new technologies, everything. For that purpose, National Mission on Quantum Computing has been bought by Government of India, okay. Apart from this, a lot of research has been going in this field, because we know with time, okay, data will become very problem for us, because we have to retrieve this data and we have to do a lot of calculations, all these things. Even for government schemes also, a lot of data will be there. So identifying beneficiaries also can be done using this quantum computers very efficiently, okay. Transferring the money will also be very efficient without any hacking by these hackers also. We can do, see, in every field we can use this quantum computers. That's why Government of India is emphasizing a lot on this quantum computers. I hope you have understood the quantum computing, the small video. Thank you, students.